Our solar system consists of 9 major planets that orbit around the Sun. The Sun is the most dominant body of the system and the source of an enormous amount of energy. This energy provides the Earth with the light and heat necessary to support life. Sunlight, emitted from the hot plasma in the Sun's outer atmosphere, is made up of a large number of photons. In physics, a photon is described as a minute particle of energy representing a quantum of light or other electromagnetic radiation. The name photon comes from the Greek phos or photos, meaning light. Photons are commonly associated with visible light, as we can see represented here, and in space all photons travel at the speed of light. The energy of a photon depends on its radiation frequency, and there are photons of all frequencies from high energy gamma and X-rays through visible light to low energy infrared and radio waves. These visible sunlight photons are heading toward the planet Earth. When they arrive, the energy they contain will be transformed in a number of ways. Photons from the Sun can be absorbed by green plants using the photosynthesis process, providing energy for the plant to grow and mature. Overexposure to photons of ultraviolet radiation from the sunlight can cause changes in a cell's DNA. This can lead to skin cancer. Photon energy can also be transformed into electricity using the photovoltaic process. The word photovoltaic was first used in the late 1800s and could be literally translated as light electricity. This is exactly what photovoltaic devices do. They convert light energy in the form of photons into electrical energy in the form of electrons. A photovoltaic cell, commonly referred to as a solar cell, is the most basic building block of all photovoltaic or solar electric system. The most common cells are made with silicon. In pure silicon, the atoms are drawn to one another to form a tight-knit crystalline structure. This makes pure silicon a poor conductor of electricity because too few of its electrons are free to move about. However, the silicon in a photovoltaic cell is mixed with impurities to alter its molecular structure. When mixed with phosphorus, the resulting silicon is called N-type silicon and contains a lot more free electrons. When mixed with boron, the resulting silicon is called P-type silicon and contains a number of missing electrons or holes in its structure. In a photovoltaic cell, the N-type silicon is placed in contact with the P-type silicon. As the free electrons from the N-type silicon rush to fill the holes in the P-type silicon, an electrical field forms. This electrical field is called the p-n junction. The combining of electrons and holes in the p-n junction eventually creates a barrier that makes it increasingly difficult for additional electrons to cross from the N-type silicon to the P-type silicon. Equilibrium has been reached. When light in the form of photons hits the cell, then its energy will free further electrons and create more holes. This creates more electrical imbalances in the cell. By placing electrical contacts on the top and bottom of the cell, this provides an external circuit path for electrons to flow from the N-type silicon to the P-type silicon to unite with the holes that have been left there. The resulting electron flow provides the current, and the cell's electrical field causes a voltage. With current and voltage, the result is the production of electrical power derived directly from the energy of the Sun. By replacing the top contact with a fine metallic contact grid, this shortens the distance that electrons have to travel and reduces the number of photons blocked by the contact itself. Also, as silicon is a shiny material, an anti-reflective coating is added to the top of the cell to reduce losses of energy caused by reflection. Finally, a glass cover plate is added to protect the cell from the elements. These cells come in various shapes and sizes. However, an individual cell can typically only produce a small amount of power. The modules can, in turn, be connected together to form an array. The size of an array is dictated by two main factors: the amount of sunlight available in a particular location and power needs of the consumer. The modular nature of these panels makes it simple to create a configuration to suit any project. A photovoltaic cell consists of more than just cells. Structures in which to mount the arrays of cells are also required. In some cases, these structures can track the sun's position and point their cells in the right direction. Components to convert the electricity from direct current to alternating current may also be required. Batteries to store the produced electricity for later use may also be part of the project. We are now surrounded by more simple and complex examples of photovoltaic systems than ever before. They are already an important part of our lives. Today's systems are extremely safe and reliable with projected lifetimes of 20 to 30 years. As demand increases and more research is undertaken in this area, the cost of manufacturing and installing photovoltaic systems will continue to reduce. We now live in a world that has become increasingly aware of environmental concerns associated with conventional power sources. This, coupled with the concept of an infinite supply of energy from the sun, means the future for the photovoltaic process is very bright indeed.